Sounds okay?
Sounds
Do I
good.
look at you, look at Cameron?
Oh,
I think the reason that the cloud was so important around 2013 was every company was an internet company.
The environment of Silicon Valley in 2013, you're kind of on the heels of the DevOps movement. We're moving from just pure virtualization into infrastructure as a service, AKA the cloud. And so at that point, automation tools are all the rave. People are now trying to abstract away the servers.
Cloud was starting to become important at Google. We realized this was a space that we had to participate in.
Cloud was becoming real in a very material way. We're starting to see the ascendance of Amazon as certainly something that was becoming mainstream enterprise technology.
AWS was this behemoth that was on everybody's mind.
By far, AWS is the dominant, cloud provider. They were early to the game with, S3. They built a great ecosystem, nailed it. It's a great kind of business at the end of the day. The main issue is, they were so dominant that, other people, were like, maybe we should have potentially a cloud-based business, right? Whether it's like Google or Microsoft or other companies out there. The problem was they were so kind of ahead that if you want to change the game, strategically, what do you do?
We knew that we had really good compute technology because everything that we had been doing was cloud first. Everybody was kind of feeling like, yeah, no, that's cool. They got a head start, right? Okay, cool. We are out here to compete.
Incrementalism wasn't going to actually make Google successful with GCE. How do we change things up? How do we shake the snow globe in a way that, may not be all about Google, but at least gives Google a fighting chance to be able to start grabbing some of these customers and to start being that balance against the dominance that AWS had at the time.
Google was looking for ways to apply its internal infrastructure expertise to the cloud. If we could leverage that expertise and that technology, then that would accelerate our entry into the cloud space.
So around 2013, I think the world was kind of primed for some new abstractions. This kind of set the stage for things like Docker, containerization, and eventually Kubernetes.
Docker is pretty special because almost immediately it got a lot of buzz, right? People got really excited about it. I personally am really excited about Docker. I think it's probably the most important project I've worked on. But because of the buzz, because of the excitement, I get a lot of questions, right? People come to me and they say, what the hell is Docker in the first place? I heard about it. I don't get it. Why? What's the big deal? It is a big deal. I'll start by saying that. And I think containers, the concept of containers and the implementation behind it will be a big deal for all of us. I think it will affect the way we work, the way we create software, the way we distribute it in big ways in the coming months and years. And I think that's really exciting. So that all has to do with the problem of shipping software, specifically.
The vision for Docker, the vision of Solomon Hykes for Docker, was always to be about building tools for mass innovation. Back then, there was already a lot of frameworks, languages that allowed engineers to build stuff on their own, in their own basement, and do something that could really, really matter. But the next step was really getting those things into production in a way that would scale, to the Google scale or Uber scale, and those things were not accessible to anyone really. This was really the unfair advantage of any sizable company that had the expertise to run this kind of services at scale. And this was the idea behind Docker.
I also get this other question, which is basically, what the hell is a container? Why should I care?
Before Docker, many companies knew about containers, but that was kind of the secret sauce. It's the kind of stuff that the 90% of engineers would never know about, but actually was running the big names. It was running under the hood at Google, at Heroku, at all those companies.
Google, for example, have been using containers for, 15 years. And they had this system called Borg that was actually the inspiration for Kubernetes. What I think was really unique at that time is that Docker Inc. created Docker, and it made this technology of containers so accessible, so easy to use, with immediate benefits.
The whole idea was how can we build the OS that will allow people to program the cloud in a way that abstracts away the differences, in a way that basically puts all the power in their hands without having to bother with the hardware.
What Docker did that was innovative was it took all those different mechanisms you needed and kind of bundled it up into a single tool that you could run locally, or you could run it in a data center or in the cloud.
For me, coming from the configuration management world, treating infrastructure as code, but without the right abstractions, and you see Docker for the first time, you look at that container image as a universal solution to the building and packaging of an application problem.
Docker succeeded in bridging the gap between dev and ops. It's a tool that attracted both people with an ops background and people with a dev background. And that was, I think, something that was very, very new.
Docker container totally changed container technology. People how to perspect to container technology. Right, used to be like some bunch of the alerts and create something, and now it's kind of it's so easy to using and we can deploy. But what's next?
As Docker was catching up success, commercial interest all over the world started looking at this. Why? Because we were starting to gain the mindsets of the engineers, both dev and ops.
Docker gathered a lot of momentum, right? It presented a developer experience that was really unique and really clean and really simple. And so you couldn't read Hacker News on any given week without finding some article on Docker.
As we started looking at technologies like Docker, we were like impressed by the strength of what they'd accomplished in solving a very specific problem, which was packaging up software and making it accessible. But just having a recognition or a realization that a lot more was going to be required. That as we thought about this future of being able to start creating more progressive ways of organizing, operating, and managing workloads, there was more there. We didn't know what it felt like yet. We didn't know at the time what it really meant, but we knew there was something there.
What an incredible year. It is really hard to believe how much has happened in the past year. I feel really privileged to be at a company that is changing the world. It's making a huge change. So Solomon, I think we're onto something. I think this is good.
How do you explain containers?
Yeah, so if you take some real world examples around us, let's say the holidays are coming up and you want to ship something to a loved one as a present. So let's invent the post office. And the post office says, we can ship things, but we don't want you to bring loose things to us. We don't want loose books and jewelry and money. No, you need to put it in a box. So if we extend this analogy, let's put an envelope. Now, there's going to be a cost for me to move this from one place to another. And depending on how far it is and how much it weighs, I'm going to give you a price. And you can think about that like your stamp. Now, whatever you put inside of it is up to you. So the container can support any programming language, Ruby, Python, Java, Golang, doesn't matter. To make Kubernetes efficient as the post office, we need to ask you to put it in the box. Now, the key is you now have to describe where it needs to go. We need to put an address on it. Where does it run? Who's it destined for? And how long would you like to take or willing to wait for it to get there? And so if you think about it, the post office abstracts all that away from you. You show up with your envelope and your stamp and the address, and they'll tell you, well, this will get there in 2 or 3 days. Planes can break down, cars can break down, but no one at the post office calls you when any of those things happen. They make a promise to you, right? They promise that this letter will get there in 2 days. How they do it is not of concern. So Kubernetes is built on this thing we call promise theory. Even though you have lots of machines in your Kubernetes cluster, any of them can break at any time. But Kubernetes' job is to make sure that application is always running. Just like the post office job is to make sure that letter keeps moving until it gets to its destination. Kubernetes does that for infrastructure. We abstract away all the details and allow developers to just put their app in a box, give us an address, And if they can afford the postage, we'll run it for them.
I don't think Kubernetes was possible without Docker, 100%. If Solomon hadn't done that demo in 2013, if Google hadn't needed to catch up to AWS, if CoreOS hadn't believed that Linux needed a good kick to the cloud, if Red Hat hadn't needed to think about what comes next after Linux. There's a lot of what ifs. It looks inevitable in retrospect. It did not feel that way at all throughout the entire process.
So Google getting into cloud was an interesting experience in and of itself. And the story of cloud has really been answering that question of now what? Now I have a machine, how do I make that machine useful? With all of the containerized platforms with Borg that have been built up for so long, we knew that there was a better way to offer developer platforms.
If we built the orchestration technology that would enable you to build real-world distributed systems, as Docker was becoming a well-used and well-known thing, we could create something quite powerful. And for me, it was really frankly, I'm always more the business guy. I was always more the business voice in the room. But a recognition that we needed to disrupt, that for us to be able to make inroads against Amazon's leadership in the sort of raw compute space and that sort of strength of ecosystem, I really knew we had to find that innovation step that would allow us to bring something to market that we didn't have to control, but that we could really make shine on Google's kind of more sophisticated infrastructure.
Our idea was, can we create a Borg-like system in a way that applies to cloud? And the question there, there was one question around, do we use Borg itself, or do we do something new? Or do we adapt an open source project that's already out there, something like Mesos?
We're playing with these ideas around what container orchestration would look like. We were playing with the idea of Docker. One of the key moments, the most distinct moments in my mind at least, was asking Brendan to just put together a little demo, because he was such a fast mover. Like Brendan could, you could ask him to do something and the next day he'd come back and, something would exist.
So I'm Brendan Burns. I'm one of the co-founders of the Kubernetes open source project.
I think Brendan is a creative genius. Like if you spend 2 days with Brendan, he will throw off 10 ideas, any of which could actually change the world. Like he's a very creative soul. Brendan stitched together something which I looked at and I was like, holy smokes, you've created a personal Borg cell. It was just scripts and whatnot, but I could feel it at that point. And for me, that was that moment of recognition that there was something here. We started working together on these ideas, and I don't know which of the two it was that had the crazy idea of like, well, what would it look like if we built this as an open source technology? What if we actually built the whole orchestration system as an open source project? What if we made that the thing that people could then deploy and use? What if it wasn't only available on Google, but was available everywhere?
Building a community via open source was going to be our best way to essentially establish a de facto standard.
I just wanted an opportunity to put forth an open source community that would generate a lot of attention and garner a lot of support. And then I wanted to be able to run it better than anyone else. I wanted to build out GKE as being an industry-leading destination for workloads. But I knew that the preconditions for me to have some success there were to get the whole programming model accepted by the industry, really garner innovation and strength around the technology.
The idea behind open source is the fact that everything should be available for anybody to go ahead and use, and more importantly, also to modify. Let's say you buy a piece of software off the shelf, right? You go in and you buy like, I don't know, Angry Birds. Then you're like, well, I kind of love the game, but I would like there to be another bird. I wanna write my own bird. I'm gonna call it Jigglypuff. No, okay, great. That's a trademark. That's Pokemon, I think. But anyways, I want to go and add another bird into the game, right? And you really can't do that. because you basically buy the software, you buy the right to use the software. With the open source, right, that's where the developers sit down and write the code, right? That is what makes the software go. And so with the open source, the idea is that anybody can go ahead and download or get the source code, and then they can also modify it. Many a times, especially in the thriving open source projects, there's a lot of contributors who actually work on that all the time. So it's not just like, okay, well, here's the software, it's done, right? There might be bugs there might be new features you want to put into it. So these contributors then come together and they go ahead and improve things all the time. So the open source basically means that you have the ability to view and modify the software, the source code, right? Again, what makes it software, and then be able to go ahead and use it however you see fit.
An interesting thing to understand is each of us brought our own kind of vision and goals to what we were trying to do, and also our own ideas and proposals. So there was an initial prototype. It was just Brendan, Joe, and Belay that worked on that.
Yeah, so those three of us hacking on it, so Joe, me, and Brendan, there's only so much, three developers can do. So we're kind of like showing it around the company, just kind of like getting some feedback on it, like, what do you think about this one? Take it for a spin.
The Mountain View team was where Borg was centered, and the Seattle team is where cloud was centered. And so we started communicating on a regular basis and bring the unique experience of the cloud folks who know how to build that product and work within that technology stack, and the unique experience of the Borg people who knew how Borg worked and meld those things together.
We did need to have a credible plan for a cloud product. We also needed a credible plan for differentiation. And we needed to assure management that we weren't enabling the competition.
The Seattle folks had written this prototype that they called 7, and it was very much a prototype. Going to someone like Urs and saying, we want to open source this. Urs is very analytical. He said, why? What do we get out of this? What is the advantage that this brings to Google? And so his initial response was, I don't think we need to do this.
We went through a series of reviews with the executive team where we pitched it and they were like, you're crazy, you're crazy.
Getting a big company like Google to do something new is always really difficult. Things work on sort of like, well, we'll have a meeting next week, we'll have a meeting the week after. It was stressful because it was obvious to the three of us what needed to be done. There were new projects, new ideas coming out every week, and so there's this real fear that if we didn't get on this, if we didn't get it out there, then the world was going to pass us by and we were going to try to adapt to something that we didn't have a lot of influence on.
Leadership, of course, had real concerns about Google funding our competitors through open source.
We knew what we could accomplish if unlocked to do this. There were a couple of kind of points in time, I think, that were really important for the success of the project. One was a bus ride. We were doing an off-site summit with a lot of the leadership group around Google's technical infrastructure teams. I had a chance to address the team around cloud and what it meant, etc. But ironically, on the way back, I was sitting behind Eric Brewer. And I was basically just framing up what we were trying to do.
Craig and I were discussing this on a bus ride from an off-site. At least at the beginning, Kubernetes felt too core, like too precious to open source. So I would say the starting position was no.
I was like, this is the vision, this is what we can accomplish, etc. And he got it. Like he got it quite deeply.
One of the big reasons to open source it is this change in the industry that we want, which is shift the agenda of cloud, huge agenda. Google is not big enough to do that by itself. To pull off that agenda, you have to have a lot of fellow travelers, right? And open source is the way to do that if you can get people to actually participate.
We hadn't yet got to a point where there was a sort of critical mass of influential individuals that got it enough to sway the kind of consensus of the executive group.
And at that point, it really looked like Google wasn't going to okay it. It really looked like, there was too much uncertainty about what this whole open source thing would mean. and how were we going to monetize it?
By the end of it, like, it was funny, like, we put together the sort of last final attempt, and we were going to have a meeting with Urs down in Mountain View, and I was at a point where I was like, look, I'm not even going to travel for this. Like, I know how this is going to go, so I'm going to be in Seattle. I'll be providing moral support. And I think actually Brendan led the conversation with Urs.
Brendan and I flew down there to have a meeting with some of the senior leadership, and if I remember correctly, there were 2 other folks in the room, the decision maker at the time, which was Urs, and another VP who was pretty senior, and that VP was very much against us open sourcing this stuff.
I was actually on the video conferencing session, and I saw Urs just like playing on his phone for most of the talk, and I was like, holy smokes, we've got it.
There was a turning point in the meeting where it's clear that you know, Urs was going to do it.
I've known Urs well enough at this point that if he disagreed with us, he'd be like educating us, like, you know, telling us why he disagreed with us. And so I did not see that one coming. It was a pretty high moment, actually.
We were surprised, and we were able to get it out there. And then afterwards, you know, it's, we don't get that much sun up here in Seattle, so it was nice to be able to go and relax in the sunshine and just, you know, think about, okay, now what do we do? And start that whole planning phase now that we got the okay to go ahead.
Finally, it's such a right thing to do that I think it was just more of a relief where I was like, okay, good.
We got the go-ahead to open source it, and then we had to scramble to actually get the thing ready and get it out there.
Once our plans were relatively concrete, we needed approval relatively quickly in order to be able to launch at DockerCon.
It took us about 6 months to get approval, and then we had about 3 months between approval and actually announcing it at DockerCon. By the time we actually had it announced, we had 27 Googlers' fingerprints on it. It actually took us less time to build the .1 release of it than it did to get approval to release it. We may have been working on it a little bit before we got approval, but I think we formally had about 7 people assigned to the project. But it was sufficiently exciting that people just wanted to participate.
We needed more people to join on, so we reached out around our organization, found some people who were loose, grabbed them, brought them into the project.
We just got exciting, and everyone just jumped in to do the development.
Now it was time to actually start getting the thing ready to release it. So we did a rewrite of the thing in to go, and then some of the early work that we did was creating a declarative layer on top of Docker. And that was written by Tim Hawken, and that was part of the scramble of getting stuff ready for Kubernetes.
As you all know, the hardest problem in computer science is naming, right? So here we are again, we have this project and we're trying to name it and yada, yada, yada. So 7M9 is basically a spin-off of Borg, right? Because again, we were looking at the kind of user experience. It was impossible to release with that name.
Honestly, we were desperate looking for a name, and it was Craig who I think, you know, said he was driving and with the steering wheel, and was like, you know, hey, maybe there's some sort of, you know, other language for a, you know, pilot or somebody steering it, and we ended up picking Kubernetes out of that.
Kubernetes was the name that came out because it ticked all the boxes in a sense that if you punch in Kubernetes into Google at the time, it's not like you're going to get a lot of hits.
Early on, Tim Hawken actually created the Kubernetes logo. We asked our marketing department, they're like, open source, we don't give a crap, just do whatever you want. I think they use more colorful language than that. And so Tim, who actually has a degree in graphic design, I believe, actually did the logo. So we were off to the races.